All right. Are you able to hear me clearly? Hello, everyone. Are you able to hear me clearly? All right. Great. So we discussed about the streaming job yesterday, and we were about to start the discussion on on the problems. We were here at this point where we were discussing the number of reduces yesterday. So as we talked earlier, the number of mappers are a function of, or a number of map tasks are a function of how many input splits do you have. An input split is generally a function of two things. One is how many blocks you have, and what exactly what input split format are you using. So there are many kinds of format. We will talk about it later. So based on your requirements, whether you want to process the whole file in a single shot, do you want to process 10 lines at a time, or do you want to uh, process fixed number of byte in a time. So what is the definition of your record? The way when we are dealing with plain text file, our definition of a record is a single line, and therefore we are using a plain text one. All right. All right. So in case of our word count, our conversion from block to input split was very straightforward, that our block size were very similar to input split. All right. Now coming back to the point, so the number of mappers is a function of generally number of blocks do you have, and what kind of algorithm are you using to convert a block into an input split. All right. So but number of reduces is something which you can control. Although the higher languages like Pig and Hive, they do take a call on how many reducers can they have based on the input size, but with respect to map reduce, by default, the number of reduces is 1. You can take a call on number of reduces, and the general thumb rule is if there is a lot of time being consumed in the reduce phase, number of time I mean the time that is being consumed in the reduce phase is lot, then you should generally, and if it is more than maps time, okay, if it is far more than the map time, then definitely it's a recipe for the conversion into more reduces. Okay, so you can have more number of reduced tasks. And so these guidelines give you a general idea on how many maximum tasks can you have. Okay. Also, you should note that the maximum number of reduced tasks are greater than total possible maximum tasks, so that many things can wait in parallel. All right. And so the general recommendation is find out how many maximum number of tasks can you execute on your machines. A general thumb rule is one CPU, one CPU, and one CPU, and I think it's one task. Okay, so if you have dual core, have two tasks configured on each node, by default, every node can execute two tasks in parallel, two reduced tasks in parallel. Okay, so based on your configuration, you first find out what is the maximum number of tasks can you execute. So number of nodes into maximum task per machine that can be executed simultaneously is equal to maximum number of tasks. Now, number of total reduces you should generally have between 0.95 to 1.75. Okay, and you can sometimes have far more smaller than that also if your input data is really small. Okay, so this is a general thumb rule to decide upon how many number of reduced tasks can you have. All right, now what would happen if you define 1.75 or twice of the maximum task? Or what would happen if you have too many reduced tasks? Okay, the amount of shuffling that goes on here. Okay, let me go back to the diagram. Are you able to hear me? Randhir is saying that audio is lost. All right, so where was the session number 2 audio? All right, not audio. I'm looking for a nice diagram. We had discussed about it. Yeah, here it is. All right. So in this diagram, you can see that the total number of network transfers, this represents the network transfer. If you have more number of reduces, there will be more number of network transfers. So if you have two and the two reduce task and three mapper task, so the total number of transfer is 3 into 2. If you have three reduced tasks and three map tasks, the total number of transfers would be 3 into 3. Therefore, as we grow, as we increase the number of maximum tasks, okay, as we increase the number of maximum tasks, the framework load increases. But general processing on the reduce phase side become really faster, and also the chance of failure of the of the whole process become lower. Why? If you have more number of tasks, there is a more division of the work. So if so the failure will always be in a smaller section. Okay, so if a node has failed, the node will have a smaller responsibility, and therefore a smaller responsibility has failed, so it's easier to restart. Okay, so more distribution of work, more resilience, and hence the lower are the chances of failure. So, sounds good to you? Is it clear to everyone? And the maximum number of reduced tasks that can be executed on every node, okay, are governed by this particular setting. Is everyone with me? All right. Only Randhir is with me. Ganpati, Martin, Naveen, Pavan, Ravi, Sharyu, Sridhar, Suresh, Sushant, Veena. All right. So everybody seems to be with me in this. Any questions at this point? Should we proceed to the problem discussions? Great, great. All right. So if you have to compute the frequencies of the letters, as in A to Z, not the 0 to 9, only A to Z. So, do you require MapReduce? You are given plain text files and you have to compute the frequency of letters. Do you require MapReduce? If so, what will be your code? So, how many of you, yeah, what is your point? So, can you do you think that we require MapReduce for even computing the frequency of letters? Yes, no. Martin says yes, Randhir says yes, Sridhar says yes, Pavan says yes, Ganpati says depends on the file size. Ravi says yes if the file size is huge. Good, good going, good going, great. So, and now let me ask you another question. All right. Okay, so depends on the file size. This is a good answer. So whenever we are solving any big data problem, the important thing which you need to ask anybody is what kind of data are we talking about? All right, what kind of data are we talking about? Is it in gigabyte or is it in? Okay, so all right. So the question is my further question is how much data, how big file, or let me rephrase, at what size of the file should we move to to map reduce? Good, good. Veena says around 15 gigabyte. Randhir says few GB size. Ravi Azmera says that greater than block size. All right, this I wouldn't really agree with. Okay, so the way you generally do is you do a quick computation. How much time do you think transfer of 15 or reading from the disk would take for 15 gigabyte? So reading from disk, how much do you think? 1 GB takes 5 seconds. So 15 gigabyte would take around 75 seconds, which means which means it will be around 1.5 minutes. Okay, which is a good number because on an average our MapReduce task would such kind of MapReduce task if you run would take around 1 to 2 minutes. All right, and 15 gigabyte is a good size to have. The other reason for 15 gigabyte is that you cannot fit 15 gigabytes in normal machines in the memory. So you inevitably have to break it into into sections and then compute the compute the frequencies in the parts and then combine the frequencies. All right. So also, if you look at this particular problem of counting the frequencies of letters, it is not really a very memory intensive task. All you have to do is maintain an array of letters in the memory and then do it. Okay. All right. Pavan says more than 100 gigabyte. Yeah. So Ganpati says, yeah. Ganpati says that it is about the RAM. I would say this particular problem does not revolve around the RAM because you don't have to read the whole file into the memory to compute the frequencies of letter. Had it been problem of counting number of words, then it could have been a problem of RAM because you will have to maintain the previous words to count the frequency. Here we are just counting the frequency of 26 letters, right? And having an array of 26 letters is not big. It's just few bytes. It's just 26 bytes. That's all. Maybe 50 bytes. That's all. So you don't have to have a lot of memory. So the only constraint in frequency, counting the characters in frequency, is the it is the problem of IO. It is neither CPU intensive nor it's RAM intensive. It is only the IO. IO as in the input output. Generally, a computer can count this much as fast as you can read from the disk. Therefore, the only constraint in this problem is the disk speed. Therefore, therefore, you compute the whole process based on the disk speed, whatever is your bottleneck. Make sense to you? Now let's have a look at the approach. Has anybody written an approach without MapReduce? Yeah? Alright. Let me show you. It's a very straightforward approach. You create an array of integers, meaning 26. You kind of these are 26 variables. Okay? And scan the text character by character. You increase the zeroth element of this array if you encounter small a or any a. Okay? Alright? Alright? And others in between. So if you encounter B, you will increase A for first element of the array and so on. So that's a very straightforward approach. Is the approach clear to everyone? Great. So this is an approach to compute the character frequency. So keep this approach in mind. The only problem with this approach is the CPU. Okay, the problem with this approach is the disk IO or the network. If the file is located in the network, it's the network which is the bottleneck, and the disk IO which is the bottleneck. Memory and RAM is not a limitation. Memory and RAM is not a limitation. So, all right, sounds good to you? All right. So, and this IO will only become bottleneck above something like 15 to 20 gigabytes. If the data starts growing beyond that, only then this disk will become bottleneck. And in today's time, as the disk is becoming faster and other things, you might better go with say 100 gigabytes. Okay, so only in the higher end, when you have really big text, only in those cases this will become a problem. All right. And you may ask that what would we do with the frequencies of the letters? Frequencies of the letters are utilized in identifying what language are we talking in. Frequencies of the letters is a good indication to predict what language is it that we're talking in. Even though the we are writing in the Roman, and still if it's the same script, we should be able to predict the the language which we are talking in. All right, now let's see how would we solve it using the map reduce. All right, the way you the way you will solve it using map reduce is this. Let me just take Randhir's approach. Randhir, or if you have done, any of you have written the code already, please share it. Veena is saying, okay, we have Veena's code. Who else has written? Please paste your code here. It'll be easier for me. It'll be not possible for me to right now to go into the LMS. All right. So here is one of the code from from Randhir. What exactly is happening here is this. Okay. So here is the deal. So what he's doing is for each letter in the input. Okay, for each letter in the input, and if the letter is A to Z, print the letter. Perfect. And then in the reduce, you don't have to concat it. You just have to return the sum. That's it. This is good. All right. So this will return the sum of array. Yeah, sum of the array. Okay. So we can call it sum of array of counts. This is good. And so basically for each key and value, your reduce function will be called and you will just return the sum of array. Good, good. We will talk about it, the inefficiencies of this later point of time. Now you can imagine that if a text of 30 gigabyte, can somebody tell me how many characters will be there in 30 gigabyte text? How many characters would be there in 30 GB text? 30 into 10 to the power 9. That's correct, Randir? Yes, that's correct, Pavan. Pavan is saying something like this. I'll have to count. 3, 3, 3. Yes, that's correct. Something of this sort. I'm just taking an assumption here. All right. That's correct. This one answer is correct, Pavan. All right. Good. So this is what it is. Okay. This is what it is. And yeah, Bala, you're also right. So it'll be 10 to the power 9. I'm assuming that when you say 1024, okay, okay, never mind. So here we go. So Bala, it will be this. This is right one. It'll be 1024 to the power something. Okay. So now, in these many characters, there will be these many. What I'm trying to say is there will be these many keys in this, right? Because for each character, we are printing the key value. So we'll be transferring this much data across the wire. Can we optimize it? Can we make it little faster? Because at the end of day, we are only looking for 26 numbers. So if you imagine this scenario, the transfer that will happen over here before it gets reduced is too high. And that's where the combiner comes into play. We run combiner here. We run combiner here before sending it to another node. All right. But before that, can we little bit optimize it in order to make it little faster? All right. One way is we compute the frequencies of each line. For each line, we call our program, which we did here. For each line or each block of text, we run our logic, which we have written earlier. Okay, so therefore, instead of printing A1, B1, C1, D1, we are printing A10, B2, C3, C3, D5. For each block of text, for each line maybe, we are calling our program. Okay, in the mapper, we are using the program which we wrote earlier. Yes, that's correct, Ravi. So instead of just printing A1, B1, and C1, we are using this. I missed an approach pasted by Veena. Let me just go through that. All right. So Veena's approach was this. Yes. So Veena's approach is also similar to yours, Randhir. All right. Good. Good. Now moving on. All right. Is this example clear to all of us? We will consider this program again. We'll consider this program again when we talk about the combiner and partitioner. Can we use nested map reduce here? Okay. A quick answer is no. Nested map reduces are used when while reducing the values itself, we require another process. Nested map reduce, we will talk about it again. Okay, let me put it in my to-do list. Okay, I'm just putting to-do list at the top so that before closing this I can look at the top and move it to my personal to-dos. Okay, all right. So nested map reduce are good if there are too many values for a key and the reduce itself need to be further used through Hadoop rather than by ourselves. You can imagine that in your case. Okay, yes, you are right. Now, when I think about it, you are right. Here, here in our case, in this reduce, the total number of array of count is too huge to to be handled by a single node. Okay, so we'll have to think of some better alternatives because this array, you can think of it, it will be for how many? For 30 gigabytes approximately, this array will be 1 billion characters long, if assuming that each character is equally distributed. So 30 gigabytes is for 30 characters, and therefore 1 gigabyte for one character. So this array might be 1 billion characters. Yeah. So it might be difficult for one reduce phase. So we might have to find some alternative, maybe nested map reduce or something else. Okay, all right. Is everyone clear about these two approaches we talked about? This one and this one? Yeah, great. Only Randhir and Veena are clear. Arjang, Bala, Ganpati, Naveen, Pavan, Ravi, Saryus, and Sridhar, Suresh. Great, great. Are you with me? Is this clear to you? The two discussions we had? Great. Now, a little tricky question. How many of you have attempted this? Okay. The question was, you have to find anagrams in a huge text. An anagram is basically a different arrangement of letters in a word. All right. So, could you just copy paste your answers? I'll take it up. So, anybody else? Okay, so here is the answer from Randhir, and his answer is this. Let me just make it look like, let me just reformat this. Okay, I will read it out. So it's a pseudocode, pseudocode, I'll try to understand. All right, okay. So all it has done is for each word in the input, sort, okay, brilliant. This is good. This is good. And Vina's approach is, in the map function, find unique words and their lengths, split the word and compare. Alright, alright. Because see, when we are running map, your map function will be run against one record at a time. If you think about this, your approach, if you are trying to find unique words and their lengths, now if you are trying to find the word and their lengths, and I split the word and compare. Yeah, this will be quite an intensive process. You'll have to pick one word and compare with the other. And if there are millions of words, you'll have to iterate through them. All right. Okay. Okay. So Randhir has got pretty much right. Anybody else? I'll try to explain Randhir's approach in a minute. Anybody else? So what we have to do is find out find out the anagram in a given text. And what is an anagram? It's a rearrangement of letters of a word. So given this huge text, one way is that we pick one word and scan through the rest of the words to find out whether those words are anagram of this word or not. And then we continue this for all of the words in this text. It's going to be horribly expensive operation, because if you have a 1 billion words, comparing 1 billion with another billion is mammoth task. It's n square. If there are n records, we are comparing n with n, and that's n into n. Okay, so the the way we compute the differential equation order here, similarly the order of total operation is n square, because each record is being compared with against each. All right, now can we solve this problem using MapReduce? Let's say, I'll give you a couple of hints. So what exactly is anagram? Anagram is a rearrangement of letters. There are various arrangement of the letters. Can there be an arrangement which is common to all? Can we arrange each of the words such that no matter what is the input, the output arrangement is same? So, okay, whether it's cat, act, or tack, if we put some way, we produce a key which is same for all anagram. Okay, then it will be great. There are a couple of approaches which I have come across from the student itself, all right, which I never thought that those will be right, but when I looked at it, they were actually correct. All right, Ravi says the key will be actual word and sort the word. Okay, Veena says arrange the letters in alphabetic order. Brilliant, brilliant. Anybody else? Good, good. So basically, we are trying to create a key for each of the word such that the key for all of the anagrams is identical. Let's say we were trying to bring together all the words of same size. What will we do? If we are trying to bring together all the words of same size, what is it that we will do? We will make the key as the size. Okay, we'll make the key as the size and the value as the actual word, right? If we were trying to, our objective was to bring together all the words of the same size. Okay, Sridhar says get the length of key words and compare the lengths first. Now we do not have luxury of comparison. If you do the comparison, you will be doing it by yourself. The only thing we have is we have to prepare the key such that Hadoop sorts the data by that key, and when it sorts it, all the values for that key will come together. Yes. So Ravi says that take a simple word, rearrange it in alphabetic order, and it becomes the key. Perfect. All right. Any other answers other than this? Now Randir says that there is a good, interesting discussion. So another approach is S key, which is sum of the word, but it could be same for cat, okay, and BBT, isn't it? As well as B. It could be same for BAS, isn't it? Right? Yes. So Bala's question is that means we will be getting toe and tech as well in this approach. So toe and tech will not have. So which approach are we talking? The one at 46 line or the one at 37 line? Bala? Okay. All right. Yes, yes, that's correct. Yes. So he was talking about size ones. Okay. If we go by, if we go by size, okay. So yes, that's correct. That is correct. Because toe and tack both have got the same size. Yes. All right. Now, yes. So here the problem with this approach is fine. Okay, unique words and their lengths. The problem is there will be too many three-letter words. There will be too many four-letter words, and it will be impossible for us to iterate over them and compare that. It will be very big task. Okay, Ganpati says, first we need to find all the words in the text, and then each word we need to rearrange and search. Search we don't have to do. We just have to leave it to Hadoop and it will do that. We just have to rearrange and leave that as a key, and then that will solve. All right. Pavan says the sorted word is the key, and all the sorted words which equal to the key will be the values. Yes, that values will be gathered by Hadoop by itself. All you have to do is put the actual word in the value. All right, going by, okay. Wow. So these are good approaches. Here is, this is what I'm repeating your approaches. There are few more approaches which I found interesting. I'll talk about it after this one. Now, one of the approach, this seems to be the easiest approach. All right. So for each word, what we have done is we rearranged the letters. We just arranged the letters in sorted manner. Now, so you might say, why ascending order? Here I have said ascending order, as in E comes before H comes before T, right? A, C, T. Alphabetically, A comes before, C comes before T. So what have I done here? For each word in the input, I have produced the key and the value. Okay, so each key value corresponds to each word. Here, cat, the second line belongs to cat, and third line belongs to act, and so on. So for each word in my input, what am I doing is I'm generating I'm generating the rearrangement of the letters. Okay, rearrangement such that it is in ascending order, in an alphabetic order. Okay, so is this clear to you? So basically, this is what am I doing? I'm basically rearranging the letters. Okay, and no, this is not correct. This is not correct. This is not correct. Okay, there are yeah, yeah. So this is Pawan's approach. Pawan's approach is the one which I'm going to take. Sort the word is the key, and all sorted words which equals the key will be one. So yeah. All right. So Ganpati's question is, can you explain how search will be? I'll show you this. So all you did was, as part of your map program, all you did was you rearranged, you basically sorted the word alphabetically. So for THE, the key is EHT. And can you tell me what will be the key for Sandeep? Anyone? What will be the key? Yes? Yes, correct. So for key for Sandeep it will be A and then D E E N P S. All right, great. So all of you got it when I say sorting the letter by. Okay, so similarly we have done it for all of these words and put that as a key and the value. All right. So the original word becomes the value, sorted one becomes the key. Now, what Hadoop will do is Hadoop will order this input such and then group it. Hadoop will order this data and group it by the key. Okay, so now you can see that for cat, act, and tech, the key is ACT. All right, you can see that, and therefore when Hadoop groups it, the key will be ACT and these original words will be the come together. As we already talked about, what Hadoop does is Hadoop sorts your data by the key and then groups the data by the key. That's all Hadoop does. And that's what has happened here. And therefore we exploited this ability of Hadoop to solve our problem of anagrams so that our all anagrams can come together. Sounds interesting? Now Ganpati's question is why HET is not present for the word. Yeah. So for the word, what will be the key? We will sort it by alphabetically. E is the smallest letter, and the key another is EHT. Okay. We are just generating for each of the word. We are generating the key by sorting the letters, by ordering the letters alphabetically. Okay. Does it make sense now? Okay, so what exactly are we doing here? For each words in our input, we are generating the key by ordering the alphabets. The value remains the original words. Why? Because we want to bring all of these words together, right? So we need a key which is same for all the anagrams. And what could that key be? One of the things which I have come up with, or you guys have come up with, is make the key by rearranging the letters alphabetically. Because for no matter what arrangements are there in the actual word, the rearrangement will always be the same. And therefore, all the anagrams will come together. Okay? Yes. Yes, this is what. Yes, Pavan, you are right. Actually, I had seen your result question, this answer earlier. Yeah, you are right. So, yes. So, this is the approach we are actually taking. All right, good, good point. Now, the question from Sushant is how anagrams were created by Mapper. And Mapper is not creating any anagrams. We are saying that there is an input text which might contain the words which are anagrams of each other. We are not generating all anagrams. We are just bringing together if there are anagrams in this file. If there are no anagrams, fine, there will be only single word. Alright? Now there is one interesting question from Veena. What if the words are repeating? Of course, when we did the word count, words were repeating, right? So, which means in the value here, we are saying that reducer will do the distinct. Now the problem with this is there would be, what if there are too many words such as the, because for the there will be so many words and reducer will be overloaded. Okay, in those cases my suggestion is you first run the word count kind of algorithm. Okay, you run the word count kind of algorithm and then we will do the rest. All right, or we will talk about combiner operation later point of time. That is also a good strategy. All right, now the question, so what if the words are repeating? Chain it with unique words. Okay, first find unique words and then run the run this code. Okay, so chain the two map reduces together. All right, also there is a good question from Ganpati. What if HT was a valid word in the text? Here we are only finding one transformation of the word and not multiple combination. It could be multiple combination, why not? Let's have a look at it. Act is a valid word, right? Act is a valid word. You can see that. So there is nothing wrong in that. It will be the key value will be in case of EHT, the key value will be EHT and the value will be EHT. Okay, so EHT, when Hadoop groups the all the values for EHT key, it will have EHT as well as THE, right? If it has found the THE also, or maybe somewhere it might have found HET and maybe it has found again the, and so on. This is what would happen. Does it make sense, Ganpati? Right? So Ravi is saying use set instead of list. Yeah. So when we are computing the distinct, we could use the constructs provided by a programming language. All right. We could use a construct to find the unique in various ways. One of the ways is to find the set, and that's what Ravi means by that. All right. Thank you, Ravi. Yeah. Going ahead. Now, Randir's question is there a way, is there a Unix command to rearrange the word? Not that I'm aware of. I need to think about it. All right. I need to think about it. All right. It's a difficult one. All right. All right. So all we did was simple thing. As we told you earlier, all Hadoop does is given key value pairs, it orders the data and groups the data. It's a big group by clause. So, but group by on what? What is the key for group by? And that's the decision we have to take. While we exploit this quality of Hadoop, we have to tell that, hey, group by my data by this particular value. And and it will group it by that. And that's the role of identifying an algorithm, identifying a strategy to identify a valid key for which we want to bring all the values together. We want to group all the values together for that key. And that's what we did here. All right. Now, as we go forward, there are a few more examples. Now, the next one is very easier one. So probably everybody will be able to do this. So a file contains the DNA sequences of the people. Find all the people who have the same DNA. The input file contains user ID, space, the DNA, and the output we are expecting all the people whose DNA is identical. Anybody with the pseudocode? All we want to all we want to do is we want to bring all the users together who have got identical DNA. All right. There is a code from Pavan. Let me just put it here. We will discuss it after this. Okay. Looks very interesting to me. Yes, this is good. This is good for word count. And this is the strategy we actually talked about. So yes, good, good. All right, now going ahead with Randhir's answer. His his answer for this question. Please feel free to answer this particular question. We are trying to find out. We want to bring all the people together. We want to group the people together whose DNA is identical. All right, good. Let's have a look at what is Randy saying. Randy is saying is split input into user space DNA and print DNA and user. So probably he's saying that make DNA as the key. All right. Now, okay. So Ganpati, you have to tell me what should your map give as key and the value. Please keep in mind whatever key you give in your mapper, it will bring whatever key you give in the as a part of the map program. So that key, based on that key, the data will be sorted. So for each of this record will be given to your map code, the logic which is there in the map, and you have to give out a key and the value. Based on this key, Hadoop will group all the values together. All the values which have the same key will be grouped together. So you have to tell me what will be the key and what will be the value. Yes. Veena says DNA will be the key and the user is the value. Ravi says key will be DNA. Okay. And yeah. So again, what Ravi says is the key will be DNA and the value will be the list of users. But you don't have a list of user. Your map logic will get only one record at a time. And one recorded, let's say, one line. If you try to get the list of users, then the whole objective, get how will you get the list of users? Okay. Will you read the whole text once and then find the DNA and then you do that? All right, we have Pavan's answer. There are many more answers. You guys are doing pretty great. All right, keep going, Ravi. And think about your answer is 50% correct. You're there. All right. All right. Great. So Arjang says key is the DNA, value is the user. Pavan says key is the DNA, value is the user. Sushant says key is the DNA and value is the user. Ganpati says key is DNA and value is the user. And Sridhar says value is this. Okay. And what was the key? Key is the DNA and value is this list. No. So here key is the DNA and why is value this? Oh, he says key is DNA and value is this key. All right. All right. Good. So, Bala, I agree with you that this is not related to the data and this and that, but this is a very underneath what is there. If you look at this problem closely, it's a group by statement of your SQL query. All right, it's a group by statement of your SQL query, and the previous one was also similar. And the next one, when you look at it, it's basically a join. All right, the next problem when we discuss, and these are the very important problem. So I agree with you that these are not typical customer data related problems, but these are far important problems and very important right now to discuss. Okay, so I'll go through your question, okay, again, and we'll put it on the forum as well. I'll try to answer it there. Okay. Brilliant. So all of us are of the same opinion. The key is going to be the DNA and the value is going to be the user. All right, Sridhar? All right. So the answer is very straightforward. All we have to do is key is a DNA and value is the user. Now, when key is DNA and the value is user, so mapper, our map function will be called on each line again and again for all the records. And our mapper function will give out key, my key is this, value is this. Now, Hadoop will take that data and group it by the key, order it by the key and then group it and bring all the users together and give to your reduce function key an array of users, and your reduce function will just print distinct users. That's it. Okay, so that's how this map reduce works. All right, now a difficult one is coming. All right, so let me just go through few more questions. All right, all of these things. This is the question from Bala. So this part, if you think about, this is what we are discussing slowly, slowly, one step at a time. And in the last, we will combine all of these things together to make a bigger this kind of a problem, and we'll solve this kind of problem at the end of it. All right. Now, going ahead, if the input is a file containing this. All right. Good. Good. So, Ganpati, are we okay? So Veena's question is, what will it be faster if we sort the DNA first? That is exactly what Hadoop is going to do. Sort it by DNA, sort it by your key, and give out the value. All right. So you don't have to worry about that. Yes. So okay. Sushant's question is, please explain why we have to run mapper on each record. So it will be Hadoop who will be calling your mapper again and again, feeding it a record at a time. All right. It'll be Hadoop who will be calling your mapper again and again for each line. All right. We are not reading the text file. Hadoop is reading the text file. We are just telling Hadoop, hey, here is my mapper program. Here is the URL of my file. And here is my reducer. And once you are done, please save it somewhere. That's what you're going to tell Hadoop. Okay, so the sorting happens after Hadoop has collected your output of all the mapper function run. Whenever whatever is the output is spitted out by your mapper program, it will be collected by Hadoop and sorted. All right. Again, the same diagram I'll go back to here. Whatever, so each record of the input will be fed to your function inside map, and whatever is the key value generated by them will be gathered by all of the will be gathered on the reduce phase. All right. Now, all right, let's move ahead. Yes, we will we are going to write MapReduce code in Java. Okay, after this. Naveen, that was for you. Now, here is a one level up. Okay. Uh, So here is one level up. There is a same file containing DNA sequences of people. Now this biologist came along and said, you know what? All the people whose DNAs are identical or are mirror image, they belong to the same family. Let's bring these people together. They belong to the same family if they're mirror image of DNA and is same as the DNA. So, all right. Now here is the so given this file which contains the DNA sequences of people, we have to bring all those users together whose DNA is either the same, meaning identical, or is mirror image. What does it mean by mirror image? When you reverse their DNA, then it becomes same. So ACGT and TGCA are reverse of each other, which means user 1 and user 2 belong to the same family. Okay. Similarly, user 1 and user 4 belong to the same family. So what will you do to solve this? Anybody? All right, very interesting. Randir says that, okay, this is interesting. And let me just paste it. Okay, so map input. Okay, this brilliant. Now here is all right. So you split by space into user and DNA and reverse the DNA. This is probably the next line. Okay, and then good. This is so what he is doing is he's sorting these two and making it as a key after concatenating. All right. So this is a pseudocode. That's not a real code. So don't worry. All right. Now Sushant says this. Do you agree with this? Key is the sorted word and value is the user. If you look at it, AGCT and user one, I mean user one and user six will come together. Because if you sort the word ACGT and AC, it will this will also generate A and then C, then G and T, and then this will also generate. If you sort the characters, it will also generate ACGT. But these are not identical. Neither these are mirror image of each other. So user one, this is the logic will not fit into our requirement. Make sense to you, Sushant? Oh, you have already taken back the answer. All right. Sorry for the dissection. All right. So yeah. Okay. Yeah. I should have seen your next response. All right. The DNA is still the key. However, so all right. So now Ravi is saying the DNA is still the key. However, when putting the key, reverse it and see if that key exists. Now, when we say see if the key exists, we don't have access to it. Okay, we don't have access to the data being spitted by all the people, because if you think about it, whatever logic you write whatever logic you write, it is going to run parallelly over the whole cluster. All right, which means you don't have access to others. Okay, if you try to build something like a central database of keys and try to search in that, it is going to be humongously expensive. So we don't have luxury to do the search. If you think about it, if you try to search it, it will be forever. So we take a key, try to search in the rest of the data, it is going to be it is going to take forever, right? So we have to come up with a strategy such that all the users whose DNA and whose DNA is either identical or is reverse come together. Okay, one of the strategy could be, there could be many strategy, or there could be many levels which we can play. Maybe we will just first bring the anagrams together. Okay, whatever uh, maybe strategy here is, we bring the anagrams together and then in those anagrams we try to search which one is a mirror image, which one is identical, and then decide. That could be one strategy, but again that is little inefficient, because in case of DNA, most of the DNAs have the same set of characters. Okay, Pavan is saying concatenate words. Okay, words and reverse the word and sort becomes the key. Interesting. Interesting. Sort as in, should we sort it by characters or sort these two? First sort them and then, I mean, sort word by word or character by character. Pavan? All right. He's saying that he's thinking again. Okay. All right. Brilliant. You guys are on the right direction. Keep going. Ganpati is saying mapper should give DNA and the user, but DNA field should have original value and the palindrome. All right, all right, all right. Looks very interesting. Looks very interesting. Could you give an example, please? Give an example. I need to understand this. You're in the very right direction. All right. Arjang is saying that key could be s- sort of DNA and mirror of DNA. Brilliant. Keep going. Here is Pawan's answer. Pawan is saying, well, first loaded the value and this by splitting the input by this, and then we reverse the key, okay, reverse the DNA basically, and then we pick up after concatenating this if you reverse it. But that case, again, if you think about your answer, Pawan, what would happen is these two, this and this, will both, yeah, okay, you are already said that you're thinking again. All right, all right, good, good, good. Here is Ganpati's answer. Record 1 is ACGT user 1, record 2 is TGCA user 1. ACGT, okay, or user 2, did you mean to say user 2? Okay, um, this one is generating two records, are you saying that? Is this generating two records? This one and this one? This one, sorry, this one and this one. Interesting, interesting. Yes, that's also a good approach. At the end of it, you can deduplicate. Okay? But again, if you think about it, at the end of it, we will have two buckets. Okay? For if you let's just pick up the second one. All right? Let's just pick up the second one and try to do the same thing. So what will happen in this case, we will have in the case of second one, we will have this and this, right? We'll have this. When we pick up the second word, we will have the same scenario, right? Now, although these users will come together at the end of it, user 2, right? And here, user 2. This is what will happen after Hadoop takes your input, groups it by the key which you have given out, it will generate this. I'm just marking this key value pair like this. Yes, so it will generate this. Now, how will you deduplicate it? Again, you will have to come up with some strategy so that we can deduplicate it. All right, all right. Now, coming, all right, so some of you have answered it again, answered it really well. Pawan is saying we need to use a hash variable. Okay, if you use a hash variable, then that will become a memory hog. Also, a hash variable may not be available on all the nodes. Sushant is saying it key could be DNA and value could be DNA plus user. Okay, that's fine, but how will the mirror image come into play? All right. All right, so here is one of the strategies. Some of you, Arjang, and some of you have already given me this strategy. Good, I'm really happy. And almost all of you are there, almost there. Okay, so if you think about this problem again, you will be able to solve it. All right, so what we are doing here is we have to bring all the people together whose DNA is either identical or mirror image of each other. Okay, so one way is that we generate the DNA and reverse of it, and pick the one which is smaller. Okay, we pick the one which is smaller. So if you see the logic, that will generate the key which bring the people with the same family together. So if you see, for user 1, what is the key? What is the DNA? ACGT, right? And what is the reverse of ACGT? It is TGCA. And what is the minimum minimum of these two is ACGT. So this is just one strategy. Okay, you could also come up with another strategy such that you order these two words, not character by, just these two words. Okay, and put a dash between them. Whichever is smaller, you put it in front and put the second one afterwards. That's also a good strategy. So right now let's focus on this one. So what exactly are we picking out? We are reversing the reversing we are taking a key, we are taking a DNA, reversing it, and then picking the smaller one out of the reverse, or this one. Okay, which guarantees that all the nodes that have the same DNA or the mirror image will have the same key. Okay, let's take a case for ACGT. For the user 1, the DNA is ACGT, and the reverse of ACGT is, the reverse of it is TGCA. Who is smaller out of the two? Smaller of the two, okay, is smaller of ACGT and the reverse of it. Who is smaller out of this? Let's say is, we are, when we say smaller, who will, if we arrange the two by alphabetic order, who will be coming first? Okay, we could also take the max bigger, but you have to do that for all the things, all the keys. Okay, that's also equally valid. Now let's take for the second one, same logic. So so if you take for the second one, this one, reverse of this one is ACGT, and out of ACGT and TGCA, which one is smaller? ACGT. Okay, now let's pick the third one. The reverse of this one is GCA, and who is smaller out of ACG and GCA? Okay, so who is smaller? The ACG, right? So our key becomes that one. Now notice that for this one ACGT, what will be the key? For ACGT, the reverse is TCGA, and who is smaller? Who is smaller? AGCT, right? Therefore, this key is different from this key. Alright, that means user 1, user 2, and user 4 will come together, but not user 6. Alright, so when we do this, when Hadoop encounters this, let me just avoid this minor confusion there is because of the alignments. Alright, so is the approach clear? Alright, there could be other strategy here. Okay, other strategy could be, the other strategy approach 2 could be that for user 1, for these one, our key could be ACGT. Let's say we separate it by dash, and TGCA. Similarly, for this one, we reverse it and then order the two. Okay, we reverse this one and put the one which is smaller, and the for this guy, for the third one, it will be ACG dash GCA. That will be the key, and the value will of course be the user in every case. Okay, because we want to bring together, and while in the reduce, the last phase, we want the user ID in the output. Therefore, we will carry that user ID by the way of putting it in the value, because all the values will gather together. All right. Now, in this case, this dash T G C A. Okay. So similarly here. So in all of these cases, you can see that this is our key. This is our key. Okay. This is our key. So again, it will lead to the same result. Sounds interesting to you? All right. In the approach one, how will the reducer know that ACGT is user one and user two? No, we don't need to know the DNA in the output. We just need to bring the users together. That's all. All right. If you want to keep the track of original DNA, then you can put here marking it like 0 or 1, whether the key was reverse or the actual, just to keep track of find, because user 3 will either have ACG. Okay. Yeah. So Vina's question is, in the reducer, in the final, we wouldn't really know whether user 3's DNA was ACG or GCA. User 5's DNA was ACG or GCA, right? So to do that, what you can do is you can put a flag here saying the key is reverse or as such. Okay. Similarly, for here, we can say for user 1, okay. So we can put an additional flag along with it, marking that the key is a reverse or original. All right. In that case, if you want to track, make sense to you? In approach 2, Ganpati, the value is again the same as this one, the actual user ID, because that we want to carry till the end user. All right. All right, brilliant. Now let's discuss this problem after the break. All right. So let's take a break for 10 minutes. All right, let's start now. Are you back? Hi, is everybody back? Should we start now? Great. Ravi is back, Bala is back, Sushant is back, Pavan is back. All right, let's start then. So the next problem which we are going to talk about is this unusual democracy, and you would be surprised that it's not a hypothetical question. It's actually based on an algorithm called PageRank by Google. Okay, it's a similar approach. All right, the algorithm is a little bit more complicated and would be a little difficult for the beginner, but this one should give you a good heads up. So there are two objectives of this particular problem. First, to help you understand how does a join work in case of Hadoop. Second, how do we uh, second that the complex algorithms like PageRank are actually based on this huge data problem. All right. Now, so the question is like this. So in this unusual democracy, not everybody is equal. Unlike in our democracy where everybody's vote is counted as one. In this democracy, the person's vote is based on how much wealth they have. Okay, so if you think about how does Google ranks various websites, it's based on how many how many other websites are linking to them and what is the rank of those websites. Okay, so in Google's case, the rank of a website is summation of the the how many people who are linking to this website as well as what are their values. A combination of the two is what leads to the page rank. All right. So if your website is being linked by a website whose page rank is really high, you will get a better page rank. If your website is being linked by too few websites, then also then too few websites and I mean, so you will get a high rank if you are linked by some website whose page rank is higher, or too many websites whose page rank may be lower. All right. So in those two cases, your website will get a higher rank. And so in the similar way here, if a person is being voted by a rich person, is being considered as bigger votes, has got more votes, and in case it's being voted by somebody who's doesn't have a big worth, is considered as low. All right. So this is what is happening in this strange democracy, something which not many people will approve of. Okay. So so this is the objective. So objective is clear with everybody. Yeah. Now let's see what could be done. The first objective is to first find out the worth of these voters. Has anybody attempted this? Yeah, Randhir has attempted. Let me just copy his answer and in the chat. Okay, so we will first look at the worth. All right. So what he's doing is for voter in map 2. Uh, okay, so you can't do that. All right, you can't do that. So you can't really access the another map. All right, the life could have been far more easier if you could just look up like this. If you could prepare a hash table of the second one, let's say we prepare the hash table of the second one. So if this list 2 is very small, okay, If the list 2 is very small, you could just send this file to all the nodes as part of something called distributed cache while making it minus file, and this is the file. Okay, and then you can do cat file and do whatever. So this file will be available here if you put minus file in that Hadoop streaming. So one approach could have been that we take this second, the one which Randhir is talking about, we take this file, copy it to all the nodes, or get Hadoop copy it for you by making it as part of distributed cache by mentioning it minus file this. So we copy this file to all the nodes or get it copied by Hadoop. Now, and then we load this file, and while in every map we make it available. And then as part of the map, we basically look up in the second one. So for each record, we are going to look up in the second one. Also notice that we'll have to load it in the memory, which means that the second list, if it is really big, then we will overflow the memory. If the second list is really big, we are going to overflow the memory, and that's going to be a disaster. All right. So can we some way bring the voter and its worth together? Can we some way brings a votee, not voter, sorry. Can we some way bring a voter and its worth together? How can we bring the voter and its worth together, and who he has voted for? Yes, anybody else has tried solving this? Yes, anybody has tried solving this? So, by the way, the approach which Randhir has said, in which the list 2 is copied to all the nodes and we are loading it, is actually a fairly viable approach. And 90% of the problems can be solved in that way. And this is known as this approach, what is mentioned here, whereby while in case of map, we are doing a lookup in the second file. This is basically not a map. Let's call it lookup table. All right. We have prepared a lookup table, and some way we are basically providing a lookup. Now, and generally list 2 is loaded once, used all the time, and not like every time we are loading it. Okay. So this approach is called map side joins. We are trying to join the two files, and we are trying to do it using map side joins. All right. This is called map side joins. All right. Is everybody okay with what I have discussed so far? Now let's see. Now let's see what exactly should be the approach. We want to do it. We want to join the two files not by ourselves. We want Hadoop to get to it. Now, as I told you in the last discussion, we can concatenate two files. We can tell that these are the two files in the input. By putting these two files in a folder, we can tell Hadoop that these are the two files in the input directory. Or if you're calling from the Java API, we can choose the input data. All right. So first objective would be to merge the two files. Now, when you just merge these two files, okay, so if you look at it, the key is our voter here, key is a voter here. When we concatenate the two, the key is a voter here. So when when Hadoop groups this data will be disparate, as in some will be integer, some will be string. Okay, so now you can, if you look at it closely, when this data is getting merged, what exactly is happening here? All the value worth and the votees of particular voter will come together. worth and the votees will come together. A, whose worth is 5, has voted for B and C. This is the first phase of Hadoop. Okay, so when Hadoop joins it, this is what your reducer get. This is what your reducer get. Reducer gets an array which contains the worth. Reducer get key and the values. Key is the voter, and values contains first one is the worth of the voter, and the rest are the people who A has voted for. Similarly, since we have just concatenated these two files and made the first column as the key by parsing it, by splitting by space and doing all the magic. All right. Also, here instead of being it a simple object, we could put something like another identifier marking that this is the worth and this is the name of the voter. All right, we could do that. There are another ways, but the concept remains same. First, we brought all the values for the key together, okay, which means that all the people who A has voted for as well as A's worth is here. Now, as part of the reduce in this phase, what exactly are we doing? Reduce will be presented with key and these values, and reduce in the reduce code, what we will do is we will mention the worth of people. We'll say that by because A has voted for B and C and A's worth is 5, therefore B will get 5, C will get 5, and A gets nothing because of voting. Similarly, B who has voted for C and B who has voted for B whose worth is 1, so C's vote count becomes 1. C's vote count is added by 1 and B's vote count is added by 0. Similarly, for this one, we do the same thing. C has voted for F and C's worth is 11. Therefore, F has got 11 and C has got 0 because of voting. Because at the end of day, when somebody is voting for somebody, he's not getting the vote count unless somebody else votes for him. Now here, D whose worth is 12, but he has not voted for anybody. Now F who has voted for C, but F does not have a worth. Therefore, we are not adding those two here. We could add those two here also. We could say D equals to 0 and F equals to 0 and C equals to 0, but we can talk about it later. Alright, now this is the output of our first phase of MapReduce. From here till here, from these two files, we got this file because of the first phase of MapReduce. Now the second phase is very straightforward. Second phase is simply group by the key and sum by the value. And we will get the vote count of all the people. Now, where did the join happen? Had it been a simple join, we could have just said select voter, sorry, select votee, join list 1 and list 2 on voter, and after join has finished, then we will say, after we have got join, then we'll say group by votee and sum by the worth. Okay, that could have been very simple SQL query. But here we have first merged the two files, and that's how it happens in Hadoop. We basically utilize this technique to join the two files. Okay, so whatever column on which we are trying to join, whenever you see a join in which we are joining on a particular column, we make that as the key so that all the values for that particular column become your key. Okay, then all the values for that column are grouped together. So all the values for that particular key, whatever we have made as a key, will come together. Therefore, while joining the two files, you could say you could do the magic. All right. Now, here's an interesting question from Sridhar. Sridhar's question is array order always number and alphanumeric afterwards? Not really. You will have to identify it by yourself. Okay. Here, it could be something like B, comma, 5, comma, C. Yeah. Now, Veena's question is what is the data type of the value array? Good, very good question. Here, while joining, let's keep the data type as a string, and while here in the reduce phase, we will parse their values. Okay, we will identify whether something is a integer or not, and then we will take this call. Now, Naveen's question is, we always use Hadoop's compare, or do we write custom compare? You write your custom comparable, yes. Okay, those are for complex objects if you are trying to do the complex object. All right. But the concept remain exactly. All right. So Bala's question is, where can we find default data types used in Hadoop? I'll help you out, and after this, that's what we are going to do. All right. All right. Veena's question is, could you explain how the files are merged in as one? Okay. The easiest way to explain is that when we are providing the input to our first phase of map, we provide the folder rather than the file. Okay, which means both the files sitting in the same folder will be automatically merged by Hadoop for you. Okay, and will be given to the mapper. Sounds okay? There is no there is no predefined order. In what order? Generally, the values are in there is no predefined order. Generally, it picks up the files based on the file name, and then it feeds to the mapper, and mapper will decide the key, and it will order the rest of the data based on the key given out by the mapper. All right. How did we come up with the merged file here? So actually, this is what is happening internally. This is being done by Hadoop internally. All we say that my input folder is this, containing the two files. And we also write as a logic. We don't write any much of a map logic. All we write is our key is the first column and the values are this. The way to your code to mapper, it will be presented as if it's a single input containing both the files. Make sense now? All right. All right. Any questions on this right now? So there are two different MapReduce phases. In one, we first join the two tables so that we get the values. Basically, we did a worth lookup. By joining on voter, we did a lookup of worth. And then in the second one, we grouped by the votee and accumulated, summed up or aggregated the worth of the votee. Okay, so Randir's question is, so in all input file, the first word is the key. So here in your mapper logic, what will you do is read the line, identify whether it's coming from the list 1 or list 2, and accordingly take the action. Okay, for your mapper, you will get the full line in a single shot, and then from that line, you can infer who is the voter, who is the votee, whether it's a voter or the birth. All right. Now, Pawan's question is, okay, could you please write a simple map reduce to execute this? Let's do this as part of our Java assignment. All right. We'll do this as part of our Java assignment. All right, Pawan. Okay, just the command. All right, let's try to see. Imagine that you have two files, list 1 and list 2. Okay, so list 1 and list 2. All right, these are the two files, and our input folder is, imagine it's in data, mr, and input, and let's call it problem numbers 5. Is it 5? It's a 4. Okay, and under this there is list 1 and list 2, but there are two files. Okay, so and our, let's say I'm defining my map. What it does is it gets a line. All right, so those who are from the Java background, they can think of it as JavaScript background, they can think of it as function, or those who are from Java background, they can think of it as void. Here I'm saying define my function called map. Okay, and then I say key comma value, and I say line dot split. That's all I got. That's a map. And define our, and let's call it map1.py. This is my map1.py. Okay, and then, all right, now the reduce one is reduce, and so, all right, and also we don't need a function here. We'll just read from the input. Here there is while read input. Okay, so whatever, so we will keep on reading from the input and doing the split. Okay, we are reading from the input, standard input, and this is what we are doing. And then uh, or actually, how should I describe, it will be better if I write this pseudocode. Actually, map one line, and this is what we do. That's it. Okay, reduce one, and we will get the line, and what we will do is we'll say in reduce one we will get key and the values. Okay, we'll get the key and the values, and for this we will say first, uh, what was that? Yeah, so in first iteration, find worth in the values. Okay, so it'll give you the, it will give you the worth, and it will also remove the column which contain the value which is worth. Find and remove worth. Okay, and we got worth. From that we'll just iterate over the values, and then for value, for v in values, we basically print out the v comma worth. Okay, v tab this. Okay, here also we are just saying print key tab values. Okay, that's all. This is our reduce phase 1. Similarly, we will write second phase of reduce map and reduce. Okay, and once we have done that, here we will say java jar, and then we will give to path to your streaming jar. Okay, streaming jar, and then we'll say uh, input is my folder like this, and let's say phase 1. Okay, so we say problem 4 output phase 1. All right, and then once we have written the second output like this, we could say things like this is our output. Okay, this is our output, and output, and we will also say minus mapper equals to map1.py, and minus reducer is uh, say reduce1.py. Okay, I'm just writing it in very simple way. You could write it in shell or whatever. All right, here we are going to say things like this, and output. Okay, so we could write something like this here, output, and we'll say output. All right, and then again mapper. So we can execute it manually, and we will also talk about job chaining afterwards. Sounds good? All right, so yeah, so as an exercise to all of us, please try to write the pseudocode or the actual code for all these 5 problems. All right, write the pseudocode or the actual code for all these 5 problems. I have just given a vague approach. You give me the pseudocode or the actual code which is running, all right, for these 4. If right now you may not be able to write the actual code in Java, but if you are from Python or other background, you will be able to do it now. All right, so using streaming. All right, is everybody with me? Should we proceed? So the approach is clear to everyone? Yes. So that was our discussion of all the 5 problems which we had so far. Arjan, Bala, Ganpati, Naveen, Pavan, Randhir, Ravi, Saryu, Sridhar, Suresh, Sushant, Veena. Should we proceed now? So Veena's question is, do you recommend learning Python? Or is it okay if you don't know Python to be a developer? So honestly, though I am a good Java programmer, I'll be very honest with you. Though I'm a really good Java programmer, I mean really good as in I have worked in Java, written couple of products, have written more than 3-4 lakh lines of code. Okay, but still, um, I find it too much of work when it comes to writing code in Java. Okay, for the concepts for the prototype, for building, hacking something around quickly, solving things quickly. Sometimes you don't need too much of bells and whistles, and sometimes, as in most of the times, it's more about getting things done than actually constructing buildings. Therefore, in those circumstances, I prefer writing it in either in shell or python quickly. Okay, most of the prototyping work I do it using python, and I learned it quickly. It was not a big deal to learn a new language if you know a language like Java or C++ plus plus or C. Okay, so I would actually recommend it not from the professional terms, but on the personal terms, because uh, for being a good programmer is a very different ball game. If you work for a startup, or if you're building your own startup, you're building your own product, you would require tools which do things quickly, in which you can get things done quickly. But in case of an enterprise setup, you would require a programming language which has lesser chance of failure in production. In case of Python, since Python is not compiled, so it has little more chances of failure in production. Maybe you have made a mistake, typing mistake somewhere, which did not get caught during the testing, right? So if you are targeting for career and enterprise world, Python is not much required. But if you are targeting for a kind of a science career, or kind of a career in which you might like to work on your own product, or you want to do some kind of a data analysis, or maybe you just want to build small utilities, in those cases Python would be good. Okay, but if you are any programmer, whether Java, C sharp, or any other, it should not take much time for you. So, learning Python is a good book, and their own tutorial is really good if you are interested. Okay, so learning Python I found good, and their own tutorial is really good. Go with their tutorial, it will finish faster and you will feel great. I could not record my Python classes, okay, because those were, I gave one class of Python to data scientists from Dell. Okay, there was a team of data scientists who wanted to attend my Python classes. So I gave that, but I could not record because it was physical class. So, but I would strongly recommend that you go with Python, learning Python. All right. Also, there is a course which we are starting. It's being taken by somebody else. I'll just tell you. Okay. And I'm not really endorsing the course right now. Okay, so you can actually enroll for this course. I have heard great reviews about the instructor who is going to take this who is going to run this course. If you are interested, all right. Otherwise, learning Python is good enough, or going with their website is good enough. All right. Bala's question: if you know Python, can you survive in the market? Yes, I think. Okay, I'll just tell you which Python tutorial I'm talking about, and then I'll answer Bala's question. All right. Okay, so this Python tutorial, not this one. Okay, this Python tutorial I was talking about. Yes. This sounds like very big, but you don't have to worry too much. You can just start with it's pretty straightforward. So, all right. So I'm sending you the Python 2 tutorial because I strongly recommend that you start with Python 2. And also on our servers itself, you have Python 2 only. You can learn, if you don't have Python installed, don't worry, you can start from our server itself. Okay, H1, H2, H3 if you are interested. Now there's a question from Bala. Okay, the question is, if you know Python only, can you survive in market? That I don't know. That I don't know. Looks like lots of companies are moving to Python. But if you are focused on building things, actually you can do everything in Python. There is a great framework for developing web applications called Django, and it has got a very rich library for doing general purpose programming. So if you have to learn a single programming language to get things done, in my recommendation, it would be Python. Okay, while PHP might be good for website, but it may not be good for data analysis. But Python has got that great library set, which is really world class. Okay. Anyway, so all right, all right. So Pawan's question is: looks like MapReduce is mostly about parsing huge data efficiently and fast and efficiently. Are there any books, tutorials on efficient algorithm for this purpose? So those who are more interested in efficient algorithms, in my personal experience, out of all the books I've studied, the best book I have found is Programming Pearls. Okay, Programming Pearls. If you are interested in, if that is your passion, if you want to really excel at algorithms, this is something which I recommend. It's a very thin book. It's a very thin book, and it is really good. I'm a big fan of this book. All right. It's not it's not like Corman. There is another book called Corman. There it's by three four authors. Okay, but that's little too big and not interesting enough. That's little too big. It doesn't talk about too much about data. All of these algorithms which we talked about HDFS, all of this distributed computing, in programming Perls, it has been expressed in very simple words. Okay, and personally, I am quite inspired by the author of that book because that author also tries to explain very complex things in very simple words. All right, so you can have a look at this. Oh, I have. All right, now it's better. Bala is asking, Python can be used for website as well? Yes. The CloudX Lab, the whole thing which we have prepared, I have prepared it in CloudX Lab. Although, okay, so anyway, so I started developing website with shell programming, then did it in one website in C, then in Perl, then in Java JSP, and then in C sharp, one in PHP, and now in Python. Okay, so actually most of the work could be done in any programming language. All right, and for Python, the website framework which is provided called Django is actually very mature. I'm pretty happy to discover it now. All right. So I would recommend that you should go with Python Django because almost 90% of the work is already done. People are already created blogs, this uploader, this, that. There are hundreds of things when you build a website. And it's far better than the Java thing. Java is great for various kinds of enterprise stuff like building transactional architectures, building a high performance one, uh, because Python is not that high performant when it when we talk about exact in terms of running the program. To make it high performance, you have to do an extra work. All right, great. So that was a quick discussion on Python and other languages. All right, before we proceed further, before you start thinking that the MapReduce is the solution to all of the world's problem, okay, there are few things you should note. Although lots of problems could be solved using MapReduce, but there are few problems where you shouldn't use MapReduce at all. All right, there's a tendency which I see that uh, I mean the first thing developers mind thinks about is, can I solve this using MapReduce? Like the way in when we use other frameworks, there is a tendency that no matter what, we have to use this new frameworks which we have learned. Okay, so let me warn you that not every problem is suitable for MapReduce. Okay, if the job is done well by a single machine in reasonable time, there is no point in using MapReduce. MapReduce is inefficient for smaller data. If it can be done on a single machine, get it done on a single machine. Okay, using your traditional programming technique, maybe a good database would be a better choice. If you have a data already and if you are able to do the normal churning of the data using the database, normal database, it is good enough. You don't have to move to MapReduce or any of these techniques just for the sake of it. Okay, just for the sake of it. No, it is only the case when you can't handle things using a single node, as we talked about in the letter counting things, letter counting problem, where we were trying to count the number of letters, that when the data grows beyond a certain size, only then you think of MapReduce as a solution. All right, otherwise it's too much of headache. Second is, you do not use MapReduce if the computation depends on previous steps. For example, let's say you want to do the Fibonacci series. In Fibonacci series, the next value in the series is generated based on number of previous values. Okay, so by summing up previous two values, we generate the next value in Fibonacci series. All right, so there are lots of problems which are very difficult to be done parallelly. Okay, for those kind of scenario, MapReduce is not a good solution. It very difficult to utilize those. Now, sometimes you want a real-time response where your expectation of response is in milliseconds. Hadoop is not a good solution. Why? Because MapReduce, if you run, it runs at its own luxurious time. You will submit the job, it will go and do the work, and then it will not give you the response, it will put it in HDFS. So there is an inherent, the way MapReduce has been designed is to solve petabytes of data problem, to solve really big data problem, for which, and that too with with the mindset that things might fail, and in case things might fail, it has to retry things instead of giving the error to the user. In such, the design of Hadoop is with the mindset of batch wise. We will have jobs, we'll get the job done, we will let you know if we could not get it done by all possible situations, and therefore it's not suitable when we talk about the real time response. It's not suitable in those scenarios. Now the fourth thing is, when your algorithm depends on some shared global state. Imagine that the problem which we did discuss just now, where we had two lists, list 1 and list 2. Now imagine this, list 2, instead of being available to you as a file, list 2 would have been inside a central system in which you can give the user's name and then it will tell you the worth. Let's imagine that a bank had given you an API to query each person's worth. Now, if you run the mapper program, which is calling this bank's API every time for each person. Let's say bank says that, hey, I cannot give you all the people's worth in a single shot. You tell me their ID and I'll give you the worth. If you know the ID, only then I'll give you the worth. Now, for this, every key for every key, Hadoop will call this global state, call the API. It will call the API for will call the API of the bank on every key in the database. Okay, every key in this list 1. That means it's going to be horribly slow. And when something is so horribly slow, it cannot be used in case of MapReduce. Okay, you will have to find alternatives to solve this kind of problems. All right, because in case it depends on a global state, there are two sides to it. First, that global state is going to get impacted really bad. Second, second, the whole job will take horribly huge time. All right. Now, Bala's question is, especially where process B is dependent on after successful completion of process A. Yeah, some sort of like this. Now imagine this, in this list, if computation of this key was dependent on this, computation of this was dependent on this, and so on. In those cases, we cannot use MapReduce. Alright? Now Sridhar's question is, where can I find these slides in my tutorial, as in your courses? So you are here, I think here, right? So most likely it should be. So isn't this available here? Sridhar? Yeah, I think it's there. All right. All right. So those were the limitations of MapReduce. Now, when we talk about MapReduce, you should first test it on very small data, maybe a random sample of the data. Also, so this is about testing in case of streaming. We will talk about Java 1 again. So first, whenever as a thumb rule, you should test your mapper reducer on small data. And when you compute the small data, you should also compute couple of random samples of the data to be tested against. A very common mistake we have is we just test our program on the beginning of the data, and then somewhere down the line, somewhere in the middle of the data, there is really awkward records which fail badly. So you should generally test on random samples of the data. You should separately test mapper and reducer. And the good news is the streaming jobs mapper and reducer can be actually tested like this. You can actually test by, if you have a job, a MapReduce job whose input file is this and has got mapper and reducer, you can actually pipe the input file to mapper and then use the sort and then reducer. Okay. In case of Java, we will use MR unit, and to test the predictions, a general thumb rule is, because most of the time you will be using MapReduce jobs for various kinds of predictions or various kinds of uh, machine learning or kind of data predictive analytics. So in those cases, if you are using your MapReduce for predictive analytics, you generally split the data into two, and generally chronologically you divide it, and you generate the predictions of on the first set and then compare the predictions against the second set. So that's a general thumb rule of testing predictions. Okay. Now here is one more assignment to all of those. Please please code the MapReduce for these whatever things we talked about so far in any of your favorite language, and create a GitHub project with your code. Okay, and mention no big data in that GitHub project. Okay, you can go to GitHub and create a project. Why am I suggesting this? Because that would help you build learn Git. Also will be your first open source project, and maybe people find it interesting, or that way you will also get a little bit exposure. Okay, so in today's time, when you go for if you are applying for a job or something, people actually look at your GitHub profile. Okay, if you have got a good GitHub profile, as in you have contributed to many website, many open source projects, then your GitHub profile shows that, it gives the rating to your profile, and thereby that adds to a lot of your resume. So Ganpati's question is, what language do you recommend other than Java? I recommend Python. All right, because generally the programming should be fun, not the labor. And for that, you require a language in which the typing is very less. Okay, and it's easier to get things done, and therefore I recommend Java. I recommend Python. So Veena's question is, okay, this is something which I would, okay, let's just try to answer this question. Probably others also will be okay with this at this point. So Veena's question is, for a company moving to big data, what will be the role of programmer during the process? So programmer should be involved in everything. Okay. So generally when I think about the whole project, I always programmer, tester, and everybody should be involved in the decision making process. Okay. So I mean, programmer's role is to come up with the architecture as well. Come up, okay, come up with architecture. It's not only the architect's role, but it's also programmer's role to come up with an architecture, like which job will do in pig, which will do it high, with what will be the storage, and when will we use this. All of these things are also programmer's duty. Okay. Second is understanding how to achieve what. Then will be writing maybe MapReduce job. First will be writing maybe Hive job, Pig's job, or creating Hive UDF for others, Pig UDF for others, and maybe it's creating custom file readers. I'll talk about input format, custom input formats, and so on. There are actually, whatever we discuss, all of this knowledge will be, your role might be anywhere. Okay, but most important will be to understand the problem you are trying to solve. Okay, understand problem you want to solve. Yes, and then once you have decided upon this, yeah, so you might have to move some of the existing data to HDFS. For this also we will discuss again. All right. Okay. So there is a website called GitHub. Somebody is asking, Randy is asking for GitHub. You can go here and create a project here, saying like this. After you have signed up, it'll ask you for new repository. You can create a new repository. Give the repository as no big data, or you can say, yeah, KBD project, and then you can say public, and then you can create the repository. All right. Okay. So you can create a public one. Public ones are free. Private ones are paid. All right. And that's how you can do. All right. So that was something about GitHub. And then in the GitHub with Git is a source control tool. All right. Try doing it. You will get the hang of it. All right. So that was about our MapReduce. All right. So based on there's another problem I want to discuss. Based on the content from a very large text archive, formulate the next word recommendation for and for each word prepare a top 5 recommendations of the word that would go next. Okay? For example, if you have huge text, say happy birthday and and then use text. So the way it happens in case of when you are writing message to your friend, when you type happy, it automatically gives the next 5 word recommendation. This is prepared based on Hughes text archive. If you have to prepare the similar recommendation, what is it that you would do? Okay, what is it that you would do? You can download the Wikipedia, the full text, and try churning the data. Okay, so based on the content from a very large text archive, formulate the next word's recommendation. And for each word, prepare top 5 recommendation of the word that would go next. Okay, so what would you do? What is it that you would do? Anybody? All right, so you can actually try solving this problem and submit it. All right, let's continue with our discussion further. All right, so here we are. So this is one problem which we want to discuss, and I think we can leave that for the next session. And all right, here are few questions as a recap that we would like to discuss. Okay, is everybody with me? All right, so the data generated by mapper is given to reducer and then it is sorted or shuffled. Yes, no? Sridhar says no. Okay, all right, all right. Randir says no. Yeah, keep going. Yeah, Bala, let me repeat the question. The data generated from mapper is first given to the reducer and after that it is sorted. Is that correct? Yes, that's right. It is not correct. So first, yes, it is sorted before it is given to the reducer. Brilliant. Next question is, the mapper can only generate a single key value pair for an input value. True or false? All right. So our mapper, did it generate multiple keys for a single line in case of word count, or it generate only one key value for our word count? Veena, didn't it generate multiple keys in case of word count? Because each word became the key. If you remember, it was not one key. Each word became the one key and the value was one, right? All right. So the answer is false, since the mapper can generate as many keys as it wants, as many key value pairs as it wants. If you remember, even our word count example, each line was converted into many key values, right? In all the problems which we've discussed so far, we were free to generate as many key value pairs as we want. Okay? Right, Bala? Yes, in that case, our input was only a single line. But for as we go forward, we will see that there will be more text, more kind of inputs. A mapper always have to generate at least one key value pair. Is that correct or wrong? A mapper has always have to generate at least one key value pair. Is that correct or wrong? So what if we did not get when we were reading the text file in case of word count problem, if our line is empty and we got an empty line, can we choose not to give out a key value pair? Is it mandatory to give out the key value pair? If let's say we are reading a big text file and we want to ignore certain data, can we just skip it and not give out any key value pair? Yes, so it is wrong. Mapper always generates, mapper can choose not to give out any key value pair. So in simple words, a mapper can generate zero or more number of key value pairs. Okay, zero or more number of key value pairs. All right, is everybody with me? Veena is saying that in that case, reducer will not be called. Reducer will not be called if there is no key, right? All right. Now, another question is by default, there is only one reducer in case of streaming job. Yes or no? Do you remember when we used our reducer streaming job? Did it generate by default one file or two files? What did it generate one file in the first case or two files? Yes. So the default is yes. By default, there is a single key in reducer, but it can be split by specifying in this. Okay. We had shown you earlier. In case of MapReduce, the number of reducers is decided dynamically. And I think this is not true in anymore. Right? What is the role of job tracker? Quickly, executing the MapReduce logic or delegating the MapReduce logic to task tracker quickly. Great, great. So it is B. All right. Now, map logic is executed preferably on the nodes that have the required data. Yes or no? Map logic is executed preferably on the nodes that have required data. Correct. All right. Now, that's right. Now, here is a twisted version of the same question. Here is the twisted version. Map logic is always executed on the nodes that have the required data. It is always executed. Is it correct or wrong? Yes, it will be executed near the data. Okay, in case those nodes which have the data are not available, it will be executed near the data. Yes. So, Veena, it is wrong because it's not mandatory in case that particular node containing the data, if it is down or it's very busy, let's say it's very, very busy, there are lots of processes already running. Now, here is the question, where does Hadoop store the result of reducer? In HDFS or in local file system? That's right. It is HDFS. Brilliant. It won't store it in local file system. It will store it in HDFS. Alright. Now, where does Hadoop store the intermediate data such as the output of map tasks? Okay, intermediate data, as in, if you remember, mappers output will be generated, collected locally, then transferred to reducer node where it will be churned. So intermediate data has to be stored somewhere, the data which will go to the reducer. So will that data, this temporary data, kept in HDFS or local file system or in the memory? All right, it is kept in the, first in the memory, and then it is purged to local file system, and then it is carried to the network. All right, good, very good set of answers. All right, now this is something interesting. Let me see who can answer this. The whole of the HDFS block available on a node is fed to the mapper. Your mapper program will be given the whole HDFS block available on the node. Is that true or false? It is no. Okay, the answer is no. I'll explain to you in a minute. There's a question from Veena. Why do we need to? It's related to the previous one. Okay, the simple reason is this is a temporary data, and temporary data does not need to be stored in HDFS. Okay, because it's unnecessary work, because it's going to disappear anyway. When you put something in HDFS, it'll have the replication factor, it'll be stored somewhere reliably, and so on. So we don't need this temporary data. All right. Yes, Pavan, that's correct. Pavan's answer is, I'll just put it for everyone. Sometimes block might have been abruptly split. Then part of the block will be transferred somewhere, and therefore, okay, all right. So yes, so we cannot feed the whole HDFS block to the mapper, because the way HDFS block is constructed may contain partial data. Some of the data might be in another block, or some of the data might be in the previous block, right? Therefore, we cannot feed the whole data. Now, if you remember our mapper logic read the data line by line. We got the data line by line. Now, if you think about the way HDFS behaves, there would be cases where half of the line is in first block and half of the line is in second block. Maybe the one of the word is split into two, half of the word is in on one block and half of the block is on another one, right? Therefore we cannot feed the whole block to, I mean, we as in Hadoop cannot feed the whole block as such to the mapper. It has to be partial information or the boundary, the records which have been broken at the boundary have to be completed by transferring the partial record to either the previous block or the next block. Okay. So Randir's question is, isn't split the task of the mapper? Yes, but the logic is to first this is something called input split preparation. That's what we are going to describe today. All right, let's move. So, okay, there's a question based on the previous screen. The question is, why are we keeping it in the memory and then purging it to the local file system? The simple reason is efficiency. So there's a circular queue in which mapper keeps spitting out. So Hadoop will collect the key values from your program. Hadoop will collect key values from your program, and the way it collects it's a big circular queue. And this circular queue or this queue in which it's just adding, it's in-memory based. On the other end, it's purging, saving to the disk continuously. All right, now moving ahead. All right, so this part we will discuss now how to split, but before that we will discuss the MapReduce in Java. All right, so those who are curious right now, okay, have a look at this Java project. Okay, we will discuss it again in detail. Have a look at this Java project, not this one, this Java project, in which I have put the way to create the project and also capped. Just download this sample project. Okay, so download this sample project and try to follow how to create project after downloading Eclipse, and then you will be completely comfortable. All right, so download Eclipse, download this sample project, follow this video, and you will be able to run the MapReduce in Java. Today we will finish it here, and we will discuss it in detail, remaining part in the next session. All right, we are running a bit late, but do not worry, we can extend it a little bit more. All right. Okay, Ganpati's question is, next week class is at 8:30 p.m. IST or 9:30 p.m. IST. We will discuss it and let you know. Okay, we will inform you before the next week. All right, we will answer it in by end of the Monday. All right. Yep. All right, Sridhar, can you drop this question over the email? I will not be able to answer it here. All right. All right. See you on the next week, uh, in the next weekend. All right. Bala, the question was related to moving to another session. Bye bye. Have a great day. See you next week. Please finish these assignment and try to attempt this one as well. All right. Bye bye. Have a good day. All right. Have a good day, Bala. Bye Sushant. Bye Randhir. Bye Veena. Bye Ravi. Bye Sridhar. Bye Ganpati. Bye Pavan. Have a good day. Have a great week ahead. See you.